Hello, let's read the question. 100 ml of a buffer solution contains 0.1 molar each of weak acid and its salt. How many grams of NaOH should be added to the buffer so that its pH will be 6? So let us see what is they are talking about. First, they are talking about a buffer and its volume is given as 100 ml. There is a weak acid. Let us what they said is a 0.1 molar weak acid, and the salt of that weak acid it is also 0.1 molar. So this is a weak acid and this is a salt of it, so it is an acidic buffer. Now they are asking how many grams of NaOH should be added to the buffer so that its pH will be 6. So they are giving pH required is 6. That means H plus concentration required is 10 raised to minus 6. And in acidic buffer, H plus ion concentration is given by H plus ion concentration is equal to concentration of acid upon concentration of salt into Ka. So Ka is known to us H plus, that is required one over here. So NaOH कितना डालना है? So H plus is over here. So let us solve this. 10 raised to minus 6 is equal to concentration of acid upon concentration of salt into Ka is given as 10 raised to minus 5. So acid upon salt concentration is equal to this 10 raised to minus 5 goes this side, so it is 10 raised to minus 1. Now this ratio is a ratio of a concentration is also a ratio of a millimoles or a moles. We can consider this ratio as moles millimoles since the volume is going to be the same for both. So let us consider कि initial millimoles of acid is how much. So initial millimoles of HA is 0.1 into 100, which is 10. So this is the molarity into volume in ml, which is 10. Initial millimoles of sodium salt is also same, which is 10. Now if some NaOH is added, and let us say that NaOH added is x millimoles. So if I add x millimoles of NaOH, what exactly going to happen? This is going to be NaOH going to neutralize acid to give a salt plus H2O. Now NaOH added is x millimoles. The acid millimole is 10 over here. This is the limiting reagent because acid has to be remain क्योंकि acidic buffer रहने वाला है. So this is limiting reagent. So leftover acid is going to be 10 raised to minus x, and this sodium salt form will be x. So the new millimoles, that is the final millimoles, are going to be of acid. The millimoles of acid, final millimoles of acid, that is millimoles of acid HA is going to be 10 raised to minus x, and final millimoles of salt is going to be 10 plus x. Now let us put this value in this equation. This is what our requirement is, that is the final one. Therefore acid is how much? 10 raised to minus x, and salt is 10 plus x, and this is equal to 10 raised to minus 1 means 0.1. Solving this, so this comes to be 10 raised to minus x is equal to 1 plus 0.1 x. So if this shifts, x shifts on this side and 1 on this side, so this will be 9 is equal to, and it is 1.1 x. So x is going to be 9 divided by 1.1, and this is the millimoles of x to be added. Now convert this millimoles into the weight. So this is a millimoles. So weight will be equal to, weight of NaOH will be equal to moles into molecular weight. So millimoles is given as 9 upon 1.1. If I write into 10 raised to minus 3 of this, so it will become moles. So this is 9 upon 1.1 into 10 raised to minus 3 into 40. So if we calculate this, it comes to be 0.327. Let's see, is it there in option? 0.328. This is in option. So option A is correct. 0.327 gram of NaOH should be added, so that buffer pH will be 6.